And welcome back to my channel, and in this video we are going to learn about time complexity. Generally the term time would give us that we might be thinking it finishes in any statement finishes in 1 second, 2 seconds, and so on, because the only time we know is in seconds, minutes, and hours. But the time complexity in data structures gives us that how many times each statement is executed in a code. So, based on the input cases, it is divided into three parts. One is the best case, second is the average case, third is the worst case. Best case is represented by omega, average case is represented by theta, worst case is represented by big O. So the best case calculates the minimum time the statement needs to get executed, and the worst case calculates the maximum time it takes to get executed. The average case is nothing but it tells the average time the statements take to get executed. So, coming to the different types of representations of the time complexities, for a constant, like it doesn't mean that it always has to be one. So, it can be anything 1, 2, 3, 4, so on up to some k. So, these are all the constants. So, for all the constants, the time complexity is represented as order of 1. When you compare the other one, that is exponential, it is represented with order of 2 power n. When you come to logarithm, it is order of log n. For linear, it is order of n. So let me give you a clarity. See, after finding the time complexity, if you are left out with some linear number like n plus 1 or n, so it can be written as order of n. If you are left out with something like n square plus n plus 1, here the highest power is taken. The other all powers which are less than this are neglected. So you write it as order of n square. Now when you compare this, n cube plus n square plus n plus 1. So what would be the order of this equation? Obviously, it is order of n cube, because this degree 3, it is the highest among all other elements. So the highest power is considered, and that is written inside the order. Now coming to a new concept, non-linear loop time complexity. Let's see what it tells. It states that it occurs when the number of operations does not increase in the direct proportion to input size. So it tells that if you are giving, suppose you are giving an input called n, and your time complexity, that is which you measure in order, it has to also increase like this in the same order, then this thing is called as linear. Other than order of n, like you are using the same input again, but the time complexity now varies, like it's going like order of n square, order of n cube, or you can take it as order of log n, and so on. You can take any type of example. So it is either increasing or it's either decreasing, but it's not the same. So that's the reason these all are called as non-linear, since the size which you have given the input size, and the time complexity, they don't vary proportionally. They are not directly proportional. N is not directly proportional to log n. This is not going to happen. So that's the reason non-linear is nothing but something other than order of n for size n. Now, keeping all these statements in your mind, let's solve the different types of problems which exist. See the following question and guess at the last whether it's linear or non-linear. So now, to solve problems like them, we need to consider iterations and its changes with I value. So let's take iterations and the I value. For the first iteration, the value of I is 1. In the second iteration, the value of I increases to I into 2. That is 1 into 2. That is 2. In the third iteration, it again increases 2 times. So the present I value is 2. So 2 into 2. That is 4. In the same way, if we continue some k iterations, because we don't know the number of iterations, so we consider it as k. So this would become, see, now it is like 2 square. So now this would become 2 power k. Now we need to check this condition. This condition would be true until the I value is less than n. If I is less than n, then the statement would get executed. But we need to check the condition wherein the statement becomes false. So the statement becomes false when I is greater than or equal to n. Am I right? See, if this is a number line and this is the value of n, if it tells that for these values which are less than n, the condition becomes true. But here we need the condition where we should check that it becomes false. So we'll take the value from n to greater than n. So here it becomes false. So that's what we have taken. Now what we know that after iterations, the value of I we got is 2 power k. So we'll write it over here. 2 power k is greater than or equal to n. In the next step, here we need to find the value of k. It gives us the time complexity. Okay. So anything in the power after it goes, it becomes logarithmic function. So it becomes k is greater than or equal to logarithm of n base 2. Now we can write it as k nearly equal to logarithm of n. So therefore the order of this becomes order of log n, because there is no other thing other than logarithmic function. So this is the time complexity of the following code. Now we know that the given size is n, but the time complexity is order of log n. That means it's not directly proportional. So we know that if it's not directly proportional, then it is non-linear. So this is the non-linear loop. Coming to the second example, if they give us two unknown variables, like here we don't even know what is p, and there we don't even know what is n. So for problems like them, what we need to do is we need to assume a random value of p. So we basically assume it as 0. we assume p value as 0. In many questions you would have seen I in place of p, but here there is a new variable p. So to solve problems like this, you need to assume the value of p as 0. After assuming the value of p0, now start doing the iterations. And next what the value of p changes to. So in the first iteration, the value of p would be 0 and the first I value is 1. So it would become p is equal to 0 plus 1, that is 1. In the second iteration, it becomes p is equal to 1 plus, what's the I value? It now increases to 2. So it becomes 3. You have to write the side by side values of I also. It's first 1, then it increases to 2. Next, in the third iteration, the value of I increases to 3 and the value of p now is 3 plus 3. This is the p, this is I. So it becomes 6. Now if you observe the following series, it is 0 plus 1. Next is 1 plus 2. Now if you split this term, it would become 1 plus 2 plus 3. Am I right? So for the kth iteration, the value of p would be 1 plus 2 plus so on up to k. So what is this? Sum of k natural numbers, that is k into k plus 1 by 2. Now what did I say in the last question? That we need to check the false condition of the given condition. So when would this statement become false? It would become false when p is greater than n. We know the value of p now. It is k into k plus 1 by 2. It's greater than n. Now it's k square plus k greater than 2 would go this side and this would become 2n. Now we can consider the highest power from here and also the power from here. So this would become k square nearly equal to n. That would become k nearly equal to root n. Therefore, the time complexity of this problem is under root n. So that's how you solve when an unknown variable is given in the condition. Now let's go to the next problem. So these are the different types of problems where you approach differently. So here the value of I starts from 0 and ends up to n minus 1. It is less than n, not less than or equal to. So it goes from 0 to n minus 1. 0 to n minus 1 we have n numbers. So 0, 1, 2, 3, so on up to n minus 1. For the value of I, the j goes from j equal to I to j less than n. That means j starts from I. So here the value of I is 0. So it goes from 0 to n minus 1. Here the value of I is 1. So it goes from 1 to n minus 1. Here the value of I is 2. So it goes from 2 to n minus 1. In the same way, it goes up to n minus 1. Because n minus 1 to n minus 1 is nothing but it's n minus 1 obviously. So we have to check how many times the value of j runs for every value of I. So here 0 to n minus 1, it runs n times. This runs n minus 1 times. In the same way, the value goes up to 1. We need to add up all the times we have got. For the value of I, we get the number of times the value of j runs, and we need to add up each of them to get the time complexity. So let's see how we add things up. So we add it as n plus next one is n minus 1 plus next we would have n minus 2, and the series would go up to 1. So did you notice anything from this? It's nothing but sum of natural numbers from 1 to n. And we are familiar with the formula, that is n into n plus 1 by 2. It comes out to be n square plus n by 2. Since we need to consider the highest power, so the highest power is 2 obviously. So the time complexity now would become order of n square. This is the final answer. And since here it is order of n square, which is not proportional to the n size which we have taken, so this problem also becomes a non-linear loop. Hope you all have understood what we have learned in this series, the different types of problems. One is this double iteration where you get two values I and j, and we have also learned when an unknown variable p exists, the way to solve the problem. And we have also seen how to solve a problem if something like I into 2 or I divided by 2 would be given. So that's it for this video. See you soon in the next part where we'll talk the different problems which are based on time complexities. Thanks for watching. If this video was helpful, do like, share, comment your opinions and subscribe to our channels. See you. Bye bye.